happy to have our next speaker, who is Isabella Caschetto. She's a product manager at SMA Solar, and she talks about the big picture that's kind of coming up really with solutions for all these challenges that we're having, of which the inverter is part, but which includes much, much more. And the title of her presentation is How Optimized Schedules and Revenue Stacking Make Hybrid Plants Profitable. Isabella, please.
Yeah, hello everybody. I hope you can hear me. Everything is fine, so I will share my screen. Okay, so seems to be working. Yeah, hello to the round. Thank you for having me today. As Michael already said, today I want to address a topic. First, yeah, as he said, my name is Isabella Caschetto. I am product manager in SMA Solar Technology in the large scale segment, but taking care of a very specific topic, which is more related to the energy market. It's called Camopo Energy. So we are part of SMA and especially the large scale segment, having an optimization software for large hybrid power plants. I will tackle this and also tell you a little bit the story and how we as SMA see the world and how it's evolving and which solutions we can provide. In the next couple of minutes, I would like to come across different topics. The first one is what is the major challenge we're facing currently in the energy market, especially when we have into the look of the renewable sector. Then I will talk a little bit about what possibilities we have to see when it comes to marketing such assets. And I will also explain it on a specific example for the German market. So when we have a look into the energy landscape, then we say, okay, we are now going into the next era by having already add a lot of renewables into the system, keeping going to reach the targets. But what we see right now that it's not only changing on how we are producing, distributing energy, but also this affects now the business cases of the renewable assets. Why? What we currently see is that we have a lot of regions over the world, but on the screen you can see the examples from the European market, where we are facing the challenge that we have hours where we have too much energy in the system, so then prices turns negative. This is typically the phase during noon when especially solar assets are feeding in. We have also other regions like Chile, where we already have a lot of solar assets installed and which are suffering from severe curtailments due to the fact that the grid cannot consume at any time the whole production. So we see that it's now also reflecting in the prices and the business cases of the assets. We believe that the energy market overall will reward flexibility in the future more over pure generation. And this is why especially customers which come out from the renewable sector have to deal with a new dimension, making solutions and think about how you deal with flexibility, especially with battery storage systems, and how you build and operate assets which can tackle those challenges, especially when we also think about changes in how grid services will be purchased, new markets are introduced. So in a field which is highly dynamically. So you have to think about those topics. We also see on the graph estimation in the UK how the negative price hour will increase. And with a pure PV or wind asset, you always have the situation that you are still weather dependent. And besides self-containment, there is not much option to overcome the situation. So in our point of view, it's the hybrid power plants which can solve this issue. Nevertheless, it's also adding a little bit more complexity to the asset itself and to the overall project lifetime regarding planning, building, and also operating. But you will also have more opportunities. When we talk about hybrids, what does this mean? For us, it's in the basis always the combination of a renewable generator like solar or wind with flexibility. In the most cases, we see currently the addition of battery energy storage systems, but you can also think about adding flexible loads like electrolyzers to produce green hydrogen, or any combination together with wind, solar, etc. When we again have a look into how these assets are currently placed, and especially when we talk about business models, we see two different approaches. The one we call co-located, and the other one we are calling full hybrids. So in the co-location approach, this is typically you have an existing renewable generator and then you co-locate a battery in order to take advantage of the already existing infrastructure like location and especially the grid connection capacity, which is also in some regions highly or very expensive or limited. But at the end, both asset parts are operating independently from each other. The optimization target or the task you have to do is to, don't get them into conflict by using the same grid connection point. We are focused more on the full hybrid cases, which is a new asset type, and for sure in some markets like US, it's already more familiar, but in Europe, we see increasing demand on this asset type, and here you have to treat this asset like one unit, meaning you really need a shared grid connection, you need a shared business cases, and especially a shared dispatching strategy. The use cases for such assets are also a little bit different compared to co-location or standalone, because at the end, you are adding a flexibility to the renewable generator by supporting and decoupling, I would say, the weather-dependent situation and having a more dispatchable renewable asset. So typically, those assets are used for fulfilling specific PPA constructs or profiles, using the battery to avoid curtailments or dealing with the negative price hours or these day-night shifting so that you're able to also provide more baseload profiles or especially green energy also during night times. We see this that also off-takers are having more interest in supplying or in purchasing such energy systems for data centers or even for electrolyzers. And from a technical point of view, for sure, there's the differentiation between AC or DC coupled. So the overall advantage, and this is why we think hybrids are the solution to the current and future challenges we see in the energy market by having a huge installed capacity with weather-dependent resources and a demand which is still in the structure we know it, is that you can shift energy to later times and that you can reshape the production profile of renewable assets, like this one. This said, there is a new task which is coming up and also which is for renewable IPPs and customers who are operating mostly renewable assets. A new task to do is now you not only have the flexibility, but you also have the opportunity to decide when to do what with the asset. So you have to think about, I have storage capacity, production capacity, and then depending on if you are going into a merchant approach or a PPA, you have to decide based on the price data, weather forecast data, etc., what to do with your asset in order to achieve the economic optimal solution and result for this asset, and then especially in order to operate it profitable over the lifetime. When we have a look into different energy markets, and this is why I'm always saying it depends where the plant is located, you have different surroundings and opportunities. When we look into the European market, you can typically sell your energy and buy energy on wholesale markets, so especially spot markets. We also have a very established frequency response market. We have first countries which are aiming to introduce inertia markets. If you have to look into the UK market, there's a lot of going on in different energy market products. But at the end, it's always, we see in liberalized energy markets, different options to sell and buy energy. And this is what we call at the end also the revenue stacking. So thinking about each market and each energy product you can provide with the asset has price. This is often volatile, and then it's a matter of, okay, thinking about for the next day, the next hour, the next 5 minutes, which one you should address in order to achieve the optimal result. But also having in mind that you have there an asset, which every action on it, like throughput through the battery, causes degradation. Production capacity has also its cost. So each action has a price tag, and it's always a matter of what is the best mixture on using this energy capacity in the market. This is the theory, but now let's have a look into what is the solution. And the solution is that you have to create, when you combine renewable generators with batteries, schedules which are reacting to dynamic changing conditions like weather, prices, availabilities on the assets, etc., and which you have to always also put into a framework which respects rules and strategies in order to have always the right decision, I would say. I have here an example from a case which is a project in Germany. It's a PV and storage hybrid power plant, and it's engaging in the wholesale trading market. So they had an intraday and also should provide primary frequency response. On the graphic, you can see the green lines is the production curve of the PV asset. You have a forecast, it's the darker green light, and you have the lighter green line. This is the actual production. And here's the first optimization topic. You see there's no PV forecast which is always or which is 100% precise. So you will always have to deal with imbalances. And this is the first option. You can use your battery by following your forecast compared to taking some imbalance costs. So this could also be already a first optimization target. You can also see the yellow line is the SOC of the battery, and then the black spikes is at the end the real interaction with the grid. And you see these spikes are representing trades the battery is using for doing arbitraging, meaning buying energy very cheap at the market, selling it to better prices, or also using the energy from the PV asset to shifting it into later hours the day compared to direct feed-in order to achieve a better price for that. And the gray squares are these 4-hour blocks. One has to be ready and get rewarded for providing primary frequency response. So you also have to take care that your battery is ready to support the grid when there is a call in this specific time block. And in order to create those schedules, what you need, and this is where our software comes into places, this is not only a topic of having the best bidding strategy, but it's more like you have there a physical asset which is still partly depending on the weather. So you need different data. In our opinion, and this is exactly why we also believe in digitalization is the very necessary next step also for huge hybrid power plants or renewable power plants, that you always need your condition on your asset. So what is the current production from the PV asset, the SOC level from the battery, is there any outage, how much cycles we already performed for this day. So different conditions from the assets which you have to gather like in life. And then you have external factors like I already explained, prices, weather situations, rules, strategy. You have to combine in order to then think ahead for the next 24 hours, next time period. This would be the best schedule for this specific individual asset. Our software, just a short overview, is like, okay, we add another intelligence layer on the asset by using 2 parts. The first one is this commercial optimizer, which is depending on what's the individual case for your asset and the target to achieve, using this forecasting and the optimization algorithmic in order to find the best schedule, and having also mathematical models included. And the other part is you still have to execute what your brain is thinking about and displaying to say, okay, please asset also execute accordingly. So we also have the full scope EMS, meaning that you can interact with the asset and also execute the set points accordingly to say, okay, please now go left or right if you want to have a picture. So both parts come together, bringing the energy market and the physical asset together. This is from a software part. So we believe we need the data in order to also support customers by operating those assets in the future energy market and also be able to adapt on different and dynamically changing situations so that you can deal with the flexibility you have. But as I introduced previously, we are part of the SMA group, and especially for large scale, we also have the vision not only that you need to have the data and think about optimization targets, but it's also necessary to have a very flexible solution as a basis, because at the end, we all know it's still, we have to feed in the electrons into the grid in the grid conform way. So having a flexible technology basis is then the game changer. And here I brought with me that also SMA is adapting the products regarding this new trends. And as you can see here, we have a new platform, which is called the Sunny Central Flex, introduced. It's also the one which has won the Interstellar Award this year, and where we believe that with this new platform, you are future-proof for any types of asset you would like to install and run in the next years. So not only going a little bit bigger, but what is really unique is for sure the silicon carbide MOSFETs we are introducing into this product. And the second one, that it's modular based. So you really can decide if you want a PV only system first, if you want to have a hybrid case and need also the storage part. And we can also support with this kind of platform hydrogen use cases. So at the end, you have one platform, and then you can decide which use cases you want to fulfill. And you also have the option to retrofit during in the field. So if you are planning to first go with PV only or another setup and then adding later asset parts, you can go with this solution and having a very modular, flexible technology basis, which covers the challenges we discussed, for sure, also during this conference a lot. So this is also a product which together, comprehend and bring us here in the position to support customers with a very flexible solution to tackle all those challenges. Okay, so I would like to sum up a little bit. As I said, for us, we really have a look into what is going on into energy markets, because at the end, this is affecting the business cases and the long-term success of assets. And what we can see here is really that we have a new era with negative price hours, with curtailments, and that we need to find a solution how to have more flexible assets into the system. On the one hand, to deal with the still weather-dependent production capacities, but at the other hand, we heard previously from the other speakers also to provide grid-friendly and grid-supportive solutions. This means for asset owners and operators, and even in the planning and financing type, that you have to put a new dimension in your decision making, and this is the energy market. So how you can use the flexibility long term and in a profitable way. And at the end, you need a very flexible technology basis and also the right data and tools which help you to decide on the daily basis what to do with the asset. So this said, I'm coming to the end of the presentation. Thank you very much for your attention. And if there are any questions, please feel free to ask or write it into the chat.
Thanks, Isabella. Great that you put a big frame on what's really needed for the market. I think let's maybe skip the question from my side at least because we have the panel still, and then we discuss there. But nevertheless, if there are any questions from the audience, please feel free to ask something in the chat. Otherwise, I will talk to you again in the panel.